to světýlko zhasne. Ale ještě pořád je dost času.
A ještě minule jsme, počkej, tak se mi to povedlo.
Jinak mimochodem mě to ráno nechtělo pustit dovnitř tady.
Kluci říkali, že uklizečka zamčela v místnosti. Že uklizečka pustila do 105.
No.
Otevřela, kluci tam naběhli,
Ne.
zavřela a ono se to za nima zamčelo.
Ne.
Kluci říkali, nikdo jim tam nechodí na přednášku, ale někdo co má s dveřma, tak to šli vyzkoušet.
To není uklízečka, která uklízí pravidelně u mě. Ona počítá s tím, když uklízí tady. Tak když hodí jednorázový průchod, neboli mávne kartou, nic nezmáčkne, tak dostanou se dovnitř. Tady, kde jsou kliky, tak je to jednoduché. Prostě vezmu za kliku, otevřu si a jdu pryč. V Ečku jsou madla,
jasně, no.
takže tam není jak. Ale v každém Ečkový posluchárně máme poslední tlačítko světel, je takzvaný únikový tlačítko. Je to popsané. To zmáčknete a dostanete se.
A to jim vůbec nedošlo samozřejmě. Myslím, že ty by tam zoufali.
Já jsem ho otevřel na tvrdo. A tady je to samé. Jako, no, oni jsou zvyklí uklízečky, protože nemají zájem, aby sem někdo chodil. Tak oni mávnou kartou, vlezou dovnitř, uklízí to tady a vypadnou ven. A je zamčený.
Musí to řešit, jasně. Tady, já se dokážu ještě do jiné místnosti.
Okay, I would like to remind you that there's a whiteboard in the hall and you can propose your lightning talks and vote for them. And Marek Bryša will tell us about ABRT server.
So, welcome everyone. My name is Marek. I work for Red Hat. I'm a software engineer. I'm working on the ABRT team. I'm responsible for the ABRT server. Just a quick information about our team. It's just a very tiny team of 5 people. There are 2 people working on the server and 3 people working on the client. And maybe a quick poll. How many of you have seen this very nice icon? Okay. Yeah, I think most of the people that were on the talk given by Dan Wolf, was it yesterday? Yeah, the ABRT icon popped up on his presentation because his kernel has crashed. How many of you are package maintainers? How many of you maintain packages? Okay. How many of you use Btrfs? That makes okay. I'll have some interesting statistics for you. Okay. Okay, so today I'm going to talk a little bit about the overview of the ABRT client and server. I will show you some success stories, how ABRT helped to fix bugs or help developers to not fix bugs. And I will talk about how it benefits teams that are present, for example, in Fedora and also in that we have internally at Red Hat. How it helps maintainers, so if you are a package maintainer, how it can help you, and of course, if you are just a Fedora user, I will show you the benefits that it brings you. So ABRT stands for Automatic Bug Reporting Tool. The server side is for historical reasons called FAF, or the Fedora Analysis Framework. We support Fedora Linux, of course. We support CentOS from November last year. And of course, internally, we support Red Hat Enterprise Linux. The whole system is pluginable, so if you are, for example, interested in OpenSUSE or anything similar, You could just write a plugin either for the client or the server, and it should work. It's quite a lot of work, so we don't have time to support OpenSUSE. But Jakub, our excellent client engineer, has actually made a working version of the ABRT client on OpenSUSE, but since then it was a little forgotten. So yeah, we have a couple of friendly competitors. The most obvious one is in Ubuntu. This is the combination of ABRT and Error Tracker, but ABRT is only enabled on the development versions of Ubuntu, in contrast to our ABRT, which is running all the time, even in the stable versions of Fedora. And also the Error Tracker, the server that collects their crash statistics, is only accessible by registered Ubuntu developers. So it kind of, I would say, limits its impact, and we actually weren't able to get in, so we don't know actually what it does. There also is Bugsnag, that is a commercial application mostly focused on catching errors in commercial applications and also in some web applications. So I would say it's something a little different than what we do. And there is Mozilla Crash Stats. That's just a product. That's just a thing that is focused on Mozilla products, so Firefox and Thunderbird. Okay, so what is the workflow that we have on the ABRT client and server? Well, when something crashes, that is either a kernel oops. For those of you who don't know what kernel oops is, it's just a non-fatal kernel crash. The kernel tries to sort of recover from every crash if it can, because it's very unfortunate when the kernel crashes completely. We also crash so-called core crashes, that is regular C or C++ application. We are able to catch Java crashes, Python, and also Ruby crashes. But the Ruby support is not fully done yet, but it's very close to being finished. So I would say in the next month it will be completely supported. So when that happens, ABRT collects a core dump, that is the image of the memory that was allocated to the process, and also some other information like the shared objects that were loaded to the process or linked, some statistical information, like, yeah, I will get back to that later. And it's anonymous. The report is anonymous, so we by default in Fedora Linux we send it to the server by default. Yeah. And if the user wants, he or she can create a full Bugzilla very easily, and that contains a lot more information because it's not anonymous. It, for example, can contain the whole core dump. That can contain some private information, so the user has to really confirm that that is what he wants to do, that he wants to upload his core dump to Bugzilla. Okay, so the micro report, that is the thing that is sent to our server. It's just a JSON file. It contains a very simple backtrace with frames for all the threads that were running, some function names, memory addresses, build IDs, so that we can deduplicate similar crashes. It contains some statistical information like the release of the operating system, so for example Fedora 20 or 21 or CentOS, the architecture that the system is running, and some information about the packages that were related to the crash or that crashed and their versions. And in case of kernel crashes, we also collect information about the modules that were loaded, and also taint flags. Taint flags are flags that tell whether the kernel is basically running in its supported original uncrashed state. So for example, if you get once you start your system and you get one of these kernel oopses, the kernel receives a warning tent flag, and it means that the kernel may be in an undefined state. So maybe some errors that happen after the first kernel oops may not be caused by an actual error in the that was cached, but by something that happened before. Okay, so this is the soul of the process. This is the micro report, or an example of it. As you can see, it's just very simple. Simple. It's a JSON file. Okay, so what does the server actually do? This is what you see when you go to this address that is stated there. Don't DDoS it now. It's written mostly in Python. We use PostgreSQL with SQL Alchemy as a database backend. The front end is made in Flask, and for the UI we are using Patternfly. So this is just an overview of the timeline of the crashes we received in some random time frame. Okay, so the first thing, the most important thing that the server does is that it deduplicates similar crashes, or reports as we call it, into problems. So this is an example of a diff of two similar backtraces that were clustered into this one problem. So you can see there are just a couple of differences. So what we do is actually we do a Levenstein distance on the backtraces. We compute distances between the different backtraces, and we create a dendrogram and cut it off at some point. And what is left is these clusters of crashes that form different problems. So in this case, it's some kind of kernel crash. Yeah, that was two backtraces merged together to form one problem. It also does retracing in its, I would say, weaker form. It retraces file names and line numbers for core crashes, so that is C and C++ crashes. And it syncs all the debug infos, all the packages that were ever released in Fedora and CentOS and so on, to get all this information so that it can do that. And in most cases, this is all that is needed to really fix the crash, because you can tell where the problem happened, on which line, in which file. So if you want, I think you can more often fix the bug just by looking at this backtrace with file names and line numbers. By the way, the table that contains all the package dependencies in all the history of Fedora contains 530 million rows, and the queries are instantaneous. So that proves that PostgreSQL is a really good database system, and that no SQL is not necessary. Okay, so another thing it does is that it keeps track of the Bugzillas that were created by users. So as I said, if the user wants, he can create a full Bugzilla, full bug report, and that bug report is linked in our server, so that package maintainers can keep track of which Bugzillas are closed, related to which problems. Yeah. It provides some occurrence statistics. So in this case, you can see that something happened on around the beginning of July. The bug somehow stopped appearing, so maybe you made a release or something else changed, and you could tell what happened, and sort of it can help you track down the issue if it was resolved or when it started appearing and so on. Okay, so some success stories, how ABRT helped package maintainers. So this is a view of the problem. So the problem is, as I said, a composition of different bug reports. This is a problem in the kernel. You can see that it happened almost 2 million times. And on various kernel versions. But what is the important thing here is that we provide so-called probable fixes. That is, when a new version of a package is released, we keep track of it, and if the report doesn't come in, the same report doesn't come in for this release of the package, we say that this package probably fixes the issue. So package maintainers can verify that their real fix that was fixed in this bug. As you can see, the version that the developer or the package maintainer stated fixes the issue matches the version that we verified. So the maintainer can verify that the issue was really resolved. Okay, so yeah, this is just a view of the backtrace for that issue. You can see it was an issue in the Intel display driver. That's a very, very popular kernel crash lately. Okay, so also it can help you not fix bugs, because if you get a Bugzilla and you open the statistics on our server and you can see that the crash happened 3 times on Fedora 20 on one architecture, that's suspiciously rare. Usually, if it's a real issue, it happens more often. So it turns out, by contacting the reporter of the bug, that he compiled his own version of OpenSSL that was completely broken, and it caused a whole lot of issues. So our GNOME ABRT, which is the ABRT client on Fedora desktop, crashed because of that. So this was not our problem, and so we could close the issue by that. Yeah, in this case, the anonymity is a bit of a limitation, because it could happen that your system is so broken that the crash appears 1,000 times, but it's still on one machine. But we can't tell if it's on one machine or 10 machines. So this is a bit of a limitation, but there is no other way to do it. It must be anonymous. Okay, so this is a problem that affected many, many different packages. So what is the chance that the packages in themselves contain the very same issue? I would say that this is close to 0. And so the actual bug must be somewhere in a common part of all these packages. And in this case, the common part was GTK file chooser, and the maintainer of GTK, one of them, was able to track down this issue and all these Bugzillas using ABRT and fix the issue, and it fixed the bug in all those components that you have seen in the previous slide. So this would not be possible without ABRT. We would not be able to connect crashes in different components together, or only manually, which would be very painful and hard to do. Okay, so some of the benefits for teams, maintainers, and users. So this is what I call the Fedora leader view. This is a graph of how many issues, how many crashes came in every month. So you can see that in September we had about 500,000 crashes coming in for Fedora 20. Yeah, in October we had around the same, so everything is fine. But then we started receiving around 3 million crashes every month, and then even more, about 5 million. So if you are a Fedora project leader, I don't think that this would make you happy. But it makes me even more sad because I'm running the infrastructure, and when the amount of reports coming in increases tenfold in 1 month, we had a few issues. So luckily we saw the future. So in August we received new hardware, and I also had to do some modifications, some optimizations on the servers to handle this huge amount of bugs coming in. But yeah, we handled it. So right now we are receiving around 5 million reports every month. So that is 2 every second. That's quite a lot of crashes. 90% of them are kernel oopses. Most of them are related to Intel display drivers. Yeah, you can also see the top 4 most crashing components in Fedora 21 are kernel, obviously, Powerline, Evolution Data Server, and GNOME Shell. Okay. So we can also witness the transition from Fedora 20 to 21, because this is the graph of from the end of 2014 and beginning of 2015, when Fedora 21 was released and got to people's hands. So you can see that the amount of bugs coming in from Fedora 20 rapidly decreased, and the amount of bugs coming from Fedora 21 rapidly increased. So yeah. This is a view of this is the problem view. So when you go to our web page, you can just click on problems, and you will see something similar to this. So as you can see, these are top, I don't know, 10 or how many most common crashes that happened in a 1 month time frame. So yeah, everything is kernel. Some of the reports are tainted, so that's what I said. Yeah, and most of them are related to Intel display drivers, but for you, Backtrace. Okay, so this would make me a little nervous if I was using Backtrace. Okay. Yeah, the count was around 300,000 a month. So this is a view of the group called GNOME Special Interest Group. So we are using the Fedora's groups to associate different crashes to their respective package owners and package maintainers. So, for example, if you are a member of the team, you can just list the most crashing things that you are responsible for, and focus your attention to fixing these issues. So, in this case, you can see that the second most crashing issue was actually fixed. The Bugzilla was closed, and also we confirmed the fix again with the probable fix. So this can help you like focus or devote resources of fixing issues to the ones that are the most hot. We have a few filters that can help you dig down a little deeper. So, for example, if you are a kernel maintainer or kernel developer, you can search for crashes that contain modules. So in this case, I searched for crashes that contain the Backtrace module. So you can see that all these reports are tainted. That means that the kernel was in some sort of non-standard state. So maybe the issue is not that serious, but definitely if your kernel is tainted and you're using Btrfs, you should watch out. We are also able to search by function names, so and source file names and architectures and so on. So there's plenty of filters. Okay, so if you're just maintaining a few packages, you can log in to using Fedora authentication system or the OpenID part of it, and you can see we are able to or the users are able to attach their contact emails to their crashes, so you could potentially contact people that experienced the crash and ask them some more information. You can also see comments, so this is like a description of the problem that the users can attach, and also you can associate Bugzillas and so on. So you get this little admin view of your packages, your components that you're maintaining. Yeah, in the future, we would like to provide even notifications for maintainers when some new crash appears, that the maintainers will be notified immediately so that they can see if the issue is serious or not. Okay, so what are the benefits? Well, for users. The first benefit obviously is that by keeping track of all these issues and focusing our efforts to fixing the hottest problems, users get more stable system. Yeah, issues are quickly discovered and prioritized because we have a lot of statistics. We can see what issues appeared recently, and so on. Yeah, they don't have to file any huge forms or bug reports, anything like that. They just enable ABRT, and all the crashes that happen on their machines are sent to us, and they are not bothered with anything, and they are contributing to the cause and helping us prioritizing the crashes and finding new ones. And also, if they really want, they can file these Bugzillas really easily. They don't have to go through the Bugzilla's forms or anything like that. They can just use the client and upload all the information that is needed to fix the issue. Some future plans. We are almost ready with integration with CentOS's bug tracker, because CentOS uses a completely different system called Mantis bug tracker. So there was a lot of work that needed to be done. It's almost ready. Yeah, as I said, we are finishing also with the Ruby micro-report support, so full support for Ruby crashes. Something that is a requested issue by some of maintainers is filtering by package versions. Sounds simple, but is actually a little complicated. So we are going to do it, but it's not that easy as it sounds. As I said, maintainer notifications, so maintainers would be notified. For example, if certain issue appears 1,000 times, we would send them an email or use Fed message bus to notify them. On the client side, we currently do so-called security analysis. That is, we try to classify the crash from a security point of view, if it's an issue that is exploitable or not. So we would like to integrate it with our statistics on the server, so that again we can, for example, focus more efforts on issues that are security relevant or not. And also, very popular topic, containers. So we are working on that. We'll have it for sure. There's just a couple of technologies that are different, and we'll see what actually makes it out alive of the fight. But so far it seems that Docker, we'll definitely support Docker, and we'll see if we can support anything else. Yeah. So a little bit of a call to action. So definitely use ABRT client. It's enabled in Fedora by default. Turn on the auto-reporting. File all those Bugzillas. It helps make Fedora more stable. Also, if you are a package maintainer, use the ABRT server to prioritize the issues. It can really help you, or as you've seen, it can also help you not fix the issue, so you can save your time. Of course, contact us with questions, issues, feature requests, success and fail stories. We welcome any feedback. We try to make our product better and better, but we need this feedback. And of course, if you're a Python or a C engineer, we welcome any patches. So feel free to send any patches. And that's kind of all from me. So if you have any questions, I'm open to answering them. Okay, yeah. Okay, so the question was that we have a huge database of crash statistics. So, would it make sense to go to different teams responsible, for example, for different file systems and show them these statistics? Yes, of course. That's why I'm here, to spread the word, to tell people that we have these statistics and that they can use them, for free. Yeah.
So the question is, are you going to make this so you can actually kind of track duplicates from the same machine, in the sense that maybe some UID sent up with a micro report, so it's like this machine reported this same crash 20,000 times.
So the question is, can we identify the machines? Was
at least give it a unique ID.
Yeah. We can do that, but we are forbidden from doing it because that would make the report not anonymous.
Well, find a way to make it anonymous, so you just know it's a duplicate from the same machine.
We could send the system this machine ID, and that's actually what we do on Red Hat Enterprise Linux. But in Fedora, I don't think it would be approved. But we can definitely we can discuss. Okay, so can we opt-in users to do that? Probably we can, but there even was a discussion on Fedora legal list about the current state of what we are sending. So it's a legal issue also. So this is kind of complicated. But we would love to do that, but yeah, it's a question between anonymity and data privacy protection and so on. So it's not that simple as it sounds. Okay. The question. Okay. The question was, can you run your own ABRT server? Yes, you can. The server is packaged as RPMs. It's not, I would say, it's not part of Fedora as of yet, but we are working on that. But we are releasing packages on Copper, so I could point you to that. And also, we are able to run the server on OpenShift. So if the deployment would be suitable for you, that's not a problem. It's not that complicated to get the server running, actually.
Maybe in relation to that, if I manage like 100 servers, and only version has access to the internet, can I have that one server collect all the reports and then
Yeah, okay, so the question is, can you use, if you have servers that are not connected to the internet and one like gateway server, can you use that server to proxy the reports to us. On Red Hat Enterprise Linux, if you use Satellite 6.1 that is not yet released, you can do that. But I don't, I mean, it's just an HTTP request. So if you set up a sort of reverse proxy on one of your servers, you can just reverse proxy all those reports to us. That shouldn't be too difficult to do. But it's not something that we like support out of the box. But if you need to do that, you can contact me. I will like help you with that. It's not a problem. Okay. The question is, do we remove sensitive data from the reports? So this micro report is designed to not contain any sensitive data. It contains only statistical information and a backtrace. So it possibly cannot contain any sensitive data. If you are filing a full Bugzilla, you are uploading your core dump, and also you are uploading your environments and so on. But we have, on the ABRT client, we have a nice user interface to go through some sensitive keywords that may be contained in those environments and so on. So you can filter out these things, and it will highlight them for you, so you can check that you are, so that you can be sure that you are not uploading any sensitive data. But this micro report is designed to be anonymous and not contain any sensitive data. That's why we are able to send it by default automatically.
Actually, there was one single request to remove some data from our database. It was some guy from a random company who sent kernel loops with some proprietary module there. And he was insisting that the module name is intellectual property of the company and that we should not display it. And then I Googled the module name and found like hundreds of kernel loops uploaded randomly on the internet. And he was then insisting that we remove it anyway, so we removed it for him. So that's the one single case that somebody was asked us to remove that. And it's probably a discussion whether it really is or is not intellectual property, but it's not.
Any more questions? Okay.
I sometimes run conversions of some programs, so can I disable reversion for specific binaries?
Yes, you can. So the question was, can you disable reporting for specific binaries? And the answer from the audience was, yes, you can. Okay, so if there are no other questions, so I thank you for being here, and you can contact us on these pages. We have a wiki, we have a lot of documentation, so you can really dig deep into ABRT. So thank you. I'll just make a few modifications to the presentation so that it makes sense offline.
it's weird. It says refreshment is certainly hollow outside the D lecture rooms. Is that correct? D is where we are, right?
Yes, I guess I'll go find someone and ask about it.
Okay.
Can I take this?
Yeah, sure.
Hello.